Layout design rules. The physical mask layout of any circuit to be manufactured using a particular process must conform to a set of geometric constraints or rules which are generally called layout design rules. These rules usually specify the minimum allowable line widths for physical objects on chip such as metal and polysilicon interconnects or diffusion areas. The minimum feature and dimensions and minimum allowable separation such two such between two such features. If a metal line width is made too small, for example, it is possible for the line to break during the fabrication process or afterwards, resulting in an open circuit. If two lines are placed too close to each other in the layout, they may form an unwanted short circuit by merging during or after fabrication process. The main objective of design rules is to achieve for any circuit to be manufactured with a particular process a high overall yield and reliability while using smallest possible silicon area. Note that there is usually a trade-off between higher yield, which is obtained through conservative geometrics, and better area efficiency, which is obtained through aggressive high density placement of various features on the chip. The layout design rules, which are specified for a particular fabrication process, normally present a reasonable optimum point in terms of yield and density. It must be emphasized, however, that the design rules do not represent strict boundaries which separate current designs from interconnect ones. A design which violates some of the specified design rules may still result in an operational circuit with reasonable yield, whereas another layout observing all specified design rules may result in a circuit which is not functional or has very low yield. To summarize, we can say in general that observing the layout design rules significantly increases the probability of fabricating a successful product with high yield. The design rules are usually described in two ways: micron rules, in which the layout constraints, such as minimum feature sizes and minimum allowable feature separations, are stated in terms of absolute dimensions in micrometers, or lambda rules, which specify the layout constraints in terms of single parameter lambda and thus allow linear proportional scaling of all geometrical constraints. Lambda based layout design rules were originally devised to simplify the industry standard micron based design rules to allow scaling capability for various process. It must be emphasized, however, that most of these micron CMOS process design rules do not lend themselves to straightforward linear scaling. The use of lambda-based design rules must therefore be handled with caution in submicron geometrics. In the following, we represent a sample or set of lambda-based layout design rules devised for the MOS implementation system MOS process and illustrate the implementation of these rules on a section of simple layout which includes two transistors. The complete set of MOS's CMOS scalable design rules are also illustrated in plate 6 and plate 7 on pages 80 to 81. Thank you.